About resonance and formal charge today. Yesterday, hopefully you watched the video and saw the information about Lewis structures. We spent some time talking about those yesterday. Been a while maybe since we talked Lewis structures, but they should have been a complete revamp of chemistry. Even if you had regular chem, it was this stuff. Now, if you had regular chem and not honors, this is all new stuff probably. So hopefully you had honors. Okay, so if you didn't and you need extra help, come in and talk to me, okay? We'll get you there. I have a way of doing formal charge that's much easier than some of the ones that are on the internet. I think I've shared this with you guys. Like, this stuff did not come to me. Like, I had to sit down and relearn it, because by the time I started teaching AP Chem, I had been out of college for about 25 years, okay, and forgotten most of my stuff. So I ended up having to go back and watch videos on it. And formal charge was one of the things that I really, really struggled with initially. So I kept going out and finding different videos. And finally, somebody had a method of doing it that I was like, oh, that's easy. And that's the method that I teach you. Okay. But sometimes when you're struggling with material and you're going out and finding these videos, it's helpful to find it from several different people. So if you're struggling with something in here and I'm not getting through to you, go out to YouTube and find other people's videos, because sometimes just the way they phrase things, just the way they say things, it clicks. Or maybe you just needed to hear it the fourth or fifth time, okay? But I can tell you, for this formal charge, I was probably on my fifth or sixth video and maybe half a box of Kleenex in with it before I came upon this. And then it was like, oh, this is so easy. So, yeah. Okay. So let me introduce you to formal charge and resonance. All right. Essentially what resonance, Essentially what resonance is it's a way of drawing these that it's a you can have it drawn two different ways, essentially. Okay. So if we look at this first structure here, we have the double bond between the nitrogen and the oxygen on this side. If we look over here, we've got the double bond over here. Both of these are valid structures. If we were to look at bond length, okay, or bond order. Okay, well, I haven't talked about bond order yet, have I? Do I talk about that coming up? Doesn't look like it. I need to talk about that. So bond order essentially it tells you kind of the length, okay? So when you have a single bond is going to be longer than a double bond, and a double bond is going to be longer than a triple bond. It's like as you add more bonds in, they get tighter, okay? So the way I tell people to figure out bond order and bond length is to look at how many bonds you have. So for this structure on the central atom here, I have 3 bonds. How many bond sites do I have? 2. So you do 3 divided by 2, and your bond order is 1.5. Okay? And that tells you with this resonance how this is shared. So essentially what's happening with these bonds is they're all kind of they're not completely short over here and long over here. It's kind of a hybrid of the two. Okay. And it's kind of like it's shared between them. Sometimes with resonance, another way that you will see them drawn instead of doing it like this is occasionally, and I think that this is the type that they're looking for on the AP exam, but occasionally you will see it in certain sources like this. Where you have your negative charge out there, where they're trying to show resonance with only drawing it one way. Okay, so occasionally you'll see it drawn with a dashed line here to show that resonance. And this might get across to you a better kind of concept in your mind that bond order is 1.5 instead of just two and 1. Yeah.
I have a question about, can you double bond both of the oxygens? Or is it like...
You can't double bond both of the oxygens.
Why not?
Because you... Okay, so let's see here. We've got nitrogen has 5, that's 6. 6 times 3 is 18. So if we double bonded the oxygens here, then we would have too many electrons, right? Or we wouldn't have enough because these would be taken away. Nitrogen would then end up with... So if you did this, if you had it drawn like this, nitrogen has 2, 4, 6, 8, 10. It can expand its octet.
Have to have the 2 on top as well, then?
Okay, so if I take that away, then I would do that. And now oxygen would have 2, 4, 6, 8, 10. Because I've got to have 18 around. Okay, so you can't double bond that. It doesn't work. Neither oxygen nor nitrogen can expand their octets. So that's not an allowable feature. So bond length and bond order, they will ask you about those. Okay, and bond order, all you have to do is how many bonds do you have around whatever atom they're talking about. Okay, so if they're saying nitrogen here, what is the bond order for nitrogen? Well, nitrogen has 3 bonds over 2 bond sites. So its bond order is 1.5. If I have water, bond order is what? 1. Because I have 2 bonds, 2 bond sites. Okay, good. Okay. All right, so resonance is just the fact that you can draw these in 2 different features. That's going to factor in, you know, and this is a valid structure, this is a valid structure. But if they say draw all possible resonance structures, you've got to draw both of these. Don't do this guy. I just bring it up because you'll see this sometimes in text. Okay? It's kind of the lazy man's way of doing it. All right, so like I said, I did talk about bond order here. Okay, so bond length, bond angle is going to be close to 1.5. So that's essentially what I talked about on the previous page with that. Yay or nay? Makes sense? Okay, so like I said, to represent resonance here, you would just draw them this way. You always indicate an arrow going back and forth, okay? Because essentially that's kind of what's happening, you know. What's my bond order here for this guy? 1.5. Yep, we've got 3 bonds, 2 bond sites. 3 divided by 2 is 1.5. Making sense? Okay. Did it not change? Why is the screen not changing? Oh, technology. There we go. Okay. Yep. Exactly. Okay. So, formal charge, the way I teach it. And again, there's other ways of doing it. So if you are like, I don't get this, Lippy, I can't understand what you're doing, go out and watch somebody else's way of doing it. Because there are different ways. Okay? My way is should minus has. So if you remember that, you can do formal charge. Now let me explain what that means. When multiple structures are possible, formal charge then will come down to the deciding factor. Which way is the best way to draw this structure? Which way is most likely to occur in nature? Okay. Should is the number of valence electrons an atom should have. So this is counting the columns on your periodic table. 1, 2, skip a few, 3, 4, 5, 6, 7, 8. Okay. How many should it have? That number is always going to be standard. Okay. Minus, okay, the how many you actually have. So have is the number of electrons directly attached to the atom. All right. Now this is the kicker when you're calculating formal charge. This is the only time that you're going to count a line as one electron. Okay. So if we go back and we look at that oxygen that we had, okay, there's ozone. Good. Oxygen should have how many? 6. Okay. It's not demonic. It's okay. It's just electrons. We're okay. This oxygen has 1, 2, 3, 4. And remember, when we're doing formal charge, the line counts as 1. So 1, 2, 3, 4, 5, 6. 6 minus 6 is 0. All right, this oxygen, 1, 2, 3, 4, 5. So the formal charge on that central oxygen is a +1. This oxygen, 1, 2, 3, 4, 5, 6, 7, minus 7. That one is a -1. See how to do that? We're going to do more, so don't think this is the only one. Now, when you do this, if you have a molecule, all of these formal charges, when you're done, should end up being 0. If you have a polyatomic ion, the formal charge in the end, all of them should add up to be whatever charge the polyatomic ion is. So for sulfate, it's a -2. When you get done, all of these should add up to be a -2. It's a good way to kind of go back and double check your work. Did you do it right? Okay. So if you have a structure where you have more than one element in play and you end up with a negative formal charge, that most electronegatives should have the negative formal charge on it. Again, I'm going to go through some more of this. I just want to lay out some of the ground rules. Okay. So the most electronegatives should end up with a negative formal charge if you have to build it that way. If you can build a structure in which none of the atoms have a formal charge, that is the best structure. Ultimately, if you can build it without a formal charge, that is what you want. Okay? And like I said, when you're counting the has, a bond only counts as 1 electron. This is the only time, right?
So is it going for as close to 0 as possible, or the lowest possible with 0 being an exception?
No, I'm not exactly sure what you're asking.
So if you have a -2 and a -3 formal charge, do you choose the -2 or the negative?
-2. Yep. And if you can build it to where it's 0, that's what you want. Okay. All molecules will end up being 0, but if you can build it so that all of these at the end, the should minus has, where you can get it built so that all of these down at the bottom here are zeros, that's what you want. And there's different ways to build these. Like if we pulled out, especially first year chem students, if we pull out their structures when they build them, some of these structures, some of these molecules, you'll end up with 4 or 5 different options for them, especially some of the polyatomics where you've got like 4 oxygens, with a thing. And before you introduce formal charge, all of them would be valid structures because they've got the right numbers around, everything has 8 and everything is, taken care of. But there's always one right answer when it comes to this stuff. And so that's where formal charge comes into play.
So for ozone, like that one, we talked about the 2 different structures. Well, even with the other structure, it would still end up with 0. So does that mean that either one is equally right, or do you?
Well, those are resonance structures.
Okay.
So yeah, they're both right. It's just whether the double bond is on this side or this side, and that lone pair, extra lone pair is
so
flipped
formal
around.
charge isn't for resonance structures. Right?
No.
Okay.
Nope. Yep.
So, is the plus 1 and the minus 1, do they cancel each other out to make the 0? Is that why it's accurate?
Yep.
Okay.
Okay, so honestly, a lot of this is going to come down to just practicing these. Okay, so for this guy, this is incorrect structure for CO2 due to formal charge not being the lowest possible. So, what happened here? This is not right because carbon doesn't have enough. Yeah, carbon's lacking an octet here. So how many electrons did I have in play? 24? So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. All right, so if I pull this guy in, that's going to give me my double bond and everything. I'll have 8 at that point. Okay, so now we're going to check our should minus has on this now that I have it fixed. So oxygen, you said before, should have 6. This oxygen, now the way I have it drawn, has how many? 7. 2, 4, 6, 7. Remember, when we're counting formal charge, that's when the line is 1. Any other time, it's always 2. Okay? So that is a minus 1. This guy is exactly the same. Do I need to recount him, or are you okay with that?
Go ahead.
All right. Over here, this oxygen should have 6. It has 1, 2, 3, 4, 5, 6. So we're okay there. And then my carbon now, the way I have everything drawn, should have how many? 4. And it has 4. 1, 2, 3, 4. So it is 0. Now my overall charge for this guy is what? -2, and that's exactly what the ion, that's why we have it in square brackets, okay? This is carbonate ion, the carbonate ion. Okay, so we've got him taken care of. Let's see, I have practice here. Okay, so take a minute. This is an example of how, if these were drawn in regular chem and we weren't looking at formal charge, all of these would be valid structures. Okay, everything has 8 electrons. Everything is, balanced out. Try to figure out, using your should minus has, which ones of these, which one is the correct structure. Okay, the cooler?
Yeah.
I would think it would be under the sink. That's usually where I keep it. Oh, yeah, I had to send it home to Uncle Mouse yet. So she'll be sending it back. Got it? Okay. They're on my desk. I'll grab it and get them off my desk. I'm sick of them. They're on my back desk there. When you think you're done, compare your answer to the person next to you if you have someone. Who's missing next to Chase here? Who? Presley? She wouldn't have dropped my class. So many sniffly noses.
So it's the one with the lowest number when you're done adding them all up, right?
So the if you have to have a negative charge when you're done, that negative charge should be on the most electronegative atom. She dropped. Nicole's back there again. Okay. So we are going to end up with a -1 charge overall on this. And I know that because this is an ion. Okay. Anybody need more time to figure this out? Okay. Nitrogen should have 5, carbon should have 4, and sulfur should have 6. Okay, got that established. Now I'm going to do my minus has. Nitrogen has how many here? 7. 2, 4, 6, 7. So that's a -2. Carbon should have 4. It has 4. So it is at 0. Sulfur should have 6. It has 1, 2, 3, 4, 5. So it is at a +1. Our formal charge checks out here because we have a -2 and a +1. So that's where this -1 is going to come into play. Okay. Now we're going to do the same thing for this guy. Nitrogen should have 5. He has 1, 2, 3, 4, 5, 6. So he is a -1. Carbon is a -4. And sulfur is a -6. Good? Mm-hmm. So if we have to compare just these two right here, we know already that this is going to be a better structure because here we have formal charge on 2 atoms. Here we have it on 1. So we can automatically get rid of that guy just with those 2 in the lineup. Does that make sense? All right. So let's keep going here. Here we have nitrogen, 1, 2, 3, 4, 5. So he is at a 0. Carbon is at a 0. Yep, so 4, so 0. Sulfur is at 1, 2, 3, 4, 5, 6, 7. He is at a -1. All right, so we need to figure out which one's better. So which one's more electronegative, nitrogen or sulfur? Nitrogen is more electronegative than sulfur. Okay, so this is going to be your preferred structure because the negative is on the nitrogen and not the sulfur. Now, they would need to give you, this is kind of a close tie between nitrogen and sulfur. They would need to give you something that's a little bit more spread out than that. Or give you a chart of electronegativities. That's another option that they could do. Okay, you're not expected to have any of the electronegativities memorized, just kind of know the trend. Okay. Oh, there's a chart. Okay, so here's my chart. I guess I didn't have it populating up right away. So you can see here that nitrogen has a higher electronegativity than sulfur. So therefore, this is the better chart, the option. Okay. So like I said, regular chem, we would have accepted all three of these structures. But out of you guys now, only one. Oh, yeah. Come on, just work for me. Is that the next slide? Yeah, okay. All right, so determine the best chart based on formal chart here. Hydrogen is 1 and 1, so it's going to be happy with 2 electrons. You know how that works. You're essentially focusing on the carbon and the oxygen here. Which one is better? Have you already got this done? You're a senior?
Oh, I'm a junior.
That explains why you didn't get
No. Half this class is juniors, except for a few seniors.
Yeah, I know. No, I got a sophomore in here.
Oh, yeah, I'm sorry.
Dave, are you? Junior. Yeah, next Tuesday, for those of you who missed it on the video yesterday, next Tuesday we have to do our mastery prep for everyone that's not a senior. So
I like chemistry more than like that.
Are we just gonna have like a free hour then, like a person?
study hall. I had planned to give you an hour to work, just do homework that hour anyway. So luckily, I knew that this was coming. They just didn't tell us when. So I was trying to build in days to be able to have that little bit of a buffer. All right, I'm going to look at the carbon here. Carbon should have 4. It has 4. So I'm at 0 there. Oxygen should have 6. It has 6. So it is at 0. Over here, I am at 4 and 6 again for my should. My has for my carbon, 1, 2, 3, 4, 5. So that gives it a -1. Oxygen, I'm at 1, 2, 3, 4, 5. That gives it a +1. Now, I am balanced out as far as formal charge. I'm at a 0 formal charge, which I need to be for my molecule. But if the structure can be built where there is 0 formal charge on all items, that's what you want. Additionally, if we look at this, if we had to have formal charge on these, this would, oh, why did you do that? It would still be wrong because you've got the negative formal charge on the less electronegative element. So for that reason alone, it's a bad structure. Okay. Nitrate. Oh, I didn't have it drawn up here. Okay. Do I have time? Yeah, we have time. So nitrate, in case you're wondering, is NO3 with a -1 charge. See if you can determine the structure of nitrate. Some of you might have made me sick. It's my turn for the crud. I'm not happy about that. So that's what I got. They could ask us to draw all resonance options here. If they did, I would draw an arrow and I would draw another structure over here and I would have my have that drawn. And what else would I have to have drawn? Yep, I gotta draw another one down here. Arrows. And I've got to do my nitrogen in the middle. I got to have my double bond at the bottom this time. And negative. All right. And then I'm going to check my formal charge once I'm done. For this oxygen should have 6. It has 7. So its formal charge is -1. It's going to be the same for this oxygen here. Okay. This oxygen over here should have 6. It has 6, so it is at a 0. Nitrogen should have 5. It has 1, 2, 3, 4. So I'm at a +1. My overall charge, remember I had 2 oxygens here that were the same. Okay, my overall charge for the molecule then is a -1, which is what it's supposed to be based on this. And I have my negative formal charge on the more electronegative element. Okay, so these are all things that you've got to go back and kind of double check through when you're working on it. Okay, questions about this guy? Bond length. Let's talk about that. Bond length, bond order. I have 1, 2, 3, 4 divided by what? 3. So my bond length is 1.3 repeating. Yep. All right. Hydroxide. Hydroxide is OH -1, in case you've forgotten what that is. Not that we made you memorize them in chem, but you might have accidentally done it along the way. Yep, so we're good. And I gotta have a -1 there. Formal charge on my most electronegative element. Oxygen's more electronegative than hydrogen. Oxygen has a formal charge of a -1, and our molecule has an overall -1 charge. Questions on that guy? All right, hydrogen cyanide. I think there's a couple of different ways to draw this one, and this does come down to formal charge. We already did carbonate, so I don't know why I doubled that slide for the next one. When we get done with this one, go on to the sulfate ion. It's kind of a fun one. See if we have time. So hydrogen cyanide. see. I have 4, 5, 10. 2, 4, 6, 8, 10. Yeah. Were you able to get this one drawn that way, or did you draw it some other way? Good. What's the formal charge on everything on that guy? 0. Yep. And the overall then is 0. Okay. Carbonate we already did. I don't know why that slide got doubled. I'm sorry. Formal charge on each of the sulfate ions here. And I'm just going to draw that guy out because we're running out of time. So save you a little bit of time in drawing because this is an expanded octet, you guys. Although there are multiple ways of drawing this. And you should end up with a -2 charge. Charge, speaking of charge, while I'm thinking about it, charge, sometimes you'll see it written like this, and sometimes you'll see it written like this. I believe that this, the way I've got it written right now, is the more accepted way. They don't care on the AP exam. I'm just telling you this because you might end up with a professor in college that's like, you know, and they care. So just realize that, but you'll see me going either way. Okay. I don't think it really matters that much, but I don't have as big a background in chemistry as your college professors obviously will. And so they may be a little bit more sticklers on it. You know, it's not like your elementary teachers ever stuck you with sig figs or anything, you know. All right, calculate formal charge on each atom here. For this oxygen, formal charge for it is 6 minus 6, which is 0. This oxygen right here is going to be a 7, which is -1. This guy will be a -1 for the same reason. And then this guy will be a 0. What is my sulfur? Huh? Well, how many should sulfur have? 6. How many does sulfur have? 6. So it's a 0. Okay. Good?
Yeah.
And the negative formal charge is on the more electronegative elements, which are your oxygens. Okay. Resonance structures of SO2 is the next part. Oh, stop packing up. You got a second.
My marker's away.
So this guy, I've got my oxygen here double bonded to my sulfur. Okay. And there's no charge on this, so I'm not going to have to worry about that. And then if I were to draw the resonance structure for this, I would draw my back and forth arrows here. And this time I would have my double bond on this oxygen. And what's wrong with my structures the way I have them drawn right now?
Sulfur only has 3.
Right. So sulfur only had 6 electrons. I needed to get it 8. I also didn't have enough electrons around each one of them. How did I know that? I went back and double checked my work. So when you go back, when you're done, when you think you're done, go back and double check those things. Things that you need to be checking for. You need to be checking for full octets. Okay. You need to be checking for formal charge as well. Okay, so make sure you go back and double check those things. Yep.
Can you also do it with like double bonds both ways and then not draw it on S?
So you had it drawn like this.
double dot on X.
Oh, if you can draw a structure without expanding an octet, you want to do that.
But I don't,
So you would have expanded sulfur's octet by doing that.
and then it equals 0 is the same as
Yeah.
Because I don't
Yeah, but they're not going to expand the octet if they can help it.
see, it's the way to make it 0.
I understand. I get it. Chemistry.